Hi, so today I'm going to go over reading a schematic. So a lot of people say, how do you read a schematic? And this is a really loaded, incredibly loaded question because this is almost like saying, how do you read a book? I mean, well, first, do you understand the language? If you don't understand the language, do you want to learn the words in the language? Do you want to understand the alphabet of that language? Which is why I'm going over what is a resistor, what is a capacitor, what is a data line, what is a pull-up resistor, what is a transistor, because this is what a schematic is comprised of. So again, if I were to open a schematic here, let me just open the schematic and go to the first page of it. I'll go over how you quote unquote read it. Let me just shrink myself. Okay, here is a schematic. So here is the beginning of it where it tells me how everything talks to one another. So it tells me what chips are responsible for different things. So one of the things that's great about a schematic is that it helps reduce ignorance. So for example, a lot of people are calling this a GPU. This is U1400 inside of this 2010 motherboard. So U1400. This over here, they call a GPU. It is not a GPU. It is an MCP. It is not simply a graphics chip. This handles serial ATA. This handles interfacing with the main memory. This handles PCI Express lanes. This handles USB, Bluetooth, trackpad, keyboard, your webcam, your external USB connectors, your USB card reader. It controls power for a chip. It sends out signals that control power chips. It communicates with the SMC. It's much more than a simple graphics chip, but people call it the video chip because usually they're clueless. Let's see. See, video makes up a very small portion of what this thing actually does. Then it'll tell you something like the power system architecture. Again, this is handy. So the power goes to this chip. This creates power for the rest of the machine. This creates PP bus G3 hot. It talks about the CPU, vCore rail. It talks about the backlight rail, where that comes from. It gives you a basic little breakdown of how a lot of things work. But it's still, I don't really go back to look at this very often. Let's see. So let's say you're having an issue with the backlight, right? So you go over to LP8545 because it says backlight over here. So U9701. And there really is no, how do you read this? It's just a document that's filled with interconnected electronic components. So here is the chip. So, what do you see here? You see ppbus underscore SW underscore BKL. So you may be wondering, what the fuck is that? And the first time I saw that, I thought the same thing, which is why I hit Control F in my PDF reader and hit Enter until I found something that made sense. So let's see. So what is ppbus SW BKL? Here we go. So over here we have a list of power aliases. So it says signal alias. So ppbus underscore SW underscore BKL is equivalent to ppbus underscore SW underscore LCD BKLT underscore per power. And it says over here in this really tiny print that will freeze if I try to zoom in because PDF readers suck. It says 12.6 volts. So I know that I'm supposed to see 12.6 volts there. And if I keep searching for that particular power line, it'll show me all the places it shows up. So what's the rest of this circuit? So what is this? Again, if you watch the rest of my videos, you should know. So this says SW for switch. Switch is sitting right in front of an inductor. Right in front of the inductor are a bunch of large smoothing capacitors before an output. And that output is 50 volts, whereas the input of this circuit, as you saw when I searched for ppbus SW BKL, is 12 volts. So this is a circuit that takes 12 volts and turns it into 50 volts via an inductor and a switch and smoothing capacitors on output. That is a DC to DC boost circuit. What is this over here? This is a resistor going from ppbus SW LCD BKLT power to the enabled tab over here, which, as I said before, runs off of 3 volts, which you'd know if you Googled the name of the chip. So this is a resistor in series with another resistor going to ground. What is this? This is a voltage divider. Let's go over other points of this circuit. Let's see. So over here, this is a signal going to a transistor. What is the point of this? This is going to send this voltage divider. This is going to allow this voltage divider to go to ground so that the voltage over here will not be 12. And once this voltage on this P-channel MOSFET over here on the gate is lower than the voltage on the source, it's going to open and send 12.6 volts to the computer. So this is a transistor. Over here it even says this is a P-type transistor. As I explained in the transistor video, a P-type transistor is a transistor which will open and let power flow through from the source to the drain when the power on the gate is lower than the voltage on the source. So the way this works, this is an N-channel MOSFET here. When LCD backlight enable comes through on the gate, it's going to send the drain to the source, which is going to send this to ground. So assuming that this and this are both present, it's going to allow this voltage divider here going from 12 volts to ground to lower this voltage. Now, we can even figure out what that's supposed to be. So let's use a voltage divider calculator. Input voltage is 12.6 volts. Top resistor is 347000. That's 347 kiloohms. And the bottom one, 301 kiloohms. And the bottom one is 147. So 301 and 147 kiloohms. And the output voltage will be 4 volts. So here's the way this works. So when this system, when this LCD backlight enable is not coming in, this transistor is closed. So therefore, this does not have a path to ground, so this will not work as a voltage divider, which means that 12 volts is going to be on the gate of this P-channel transistor. If there is an equal voltage on the gate of the P-channel transistor as there is on the source will never flow to the drain and the light will never turn on. However, if you have an input voltage over here on LCD backlight enable, now the way this transistor works is an N-channel transistor. So when the signal on the gate is greater than the signal on the source, what's going to happen is it's going to open and send power through. So when this opens, it's going to allow this the bottom of this voltage divider here to connect to ground, and when that happens, this is no longer going to be 12 volts on the gate, it's going to be 4 volts on the gate. And since there's going to be a lower voltage on the gate than there is on the source, this P-channel MOSFET will open and send power through to the backlight rail. I'm just going to go through and just try to point out basic things in the schematic and show you how you read them. So the answer to how you read a schematic is using your knowledge of electronics that you learned through research and through going through my videos and how all these different things work. Again, I went over what a transistor does. I went over what a voltage divider does. I went over how to find the power rails in the beginning of this document. So if you say, well, I don't know that there's supposed to be 12 volts there, yes, you do, because you can simply search for that region, and in the beginning of the schematic, it will tell you that that's a subrail of a rail that creates 12.6 volts. That's a subrail of a rail that creates 5 volts. I'm spelling all this out for you so that you'll know how to read a schematic. Again, there isn't, like, how to read a schematic is simply knowing what the components are and what they do, and you learn that through learning basic electronics. There is no secret to, oh, you read the schematic by installing the schematic reader plugin for Foxit PDF. Like, no, you use your fucking brain. That's how you read a schematic. Or what is this? So you see 2 transistors being controlled by a controller chip, and then right where the output of that top transistor is, you see an inductor, and then you see a bunch of smoothing capacitors. That is a buck converter. Like, again, you should know what these things are after you have some experience. You should know what these things are after you go to the basic lessons. This is a resistor. This is a fuse. Like this over here. What is this again? So this is a DC power supply, but this is doing something. Over here you see different components. One of them is a component that thinks, the system management controller, and it's attached to different components of the machine through a line that says data. So what is this component? This is a pull-up resistor. What is this over here? This is a data line. Again, you read schematics using the knowledge that you learn through research, through education, through banging your head against the wall until it makes sense, through, let's say, watching my YouTube channel. Again, there is no plugin for Foxit PDF Reader that's like schematic reader. There is no plugin for Foxit PDF Reader that is brain. You have to figure it out. And part of what I'm trying to do with this short video series is make it easier for you to figure out all of this stuff. The other thing that's important, board view software. So one of the common things that drives me nuts, people just think I'm psychic when it comes to figuring out what is on a board. And like, well, this component does this, and that component does that, or knowing that this is the SMC. Let me be the first to tell you that I'm not psychic. I'm not. I know where this stuff is because of this little software right here. So if you've bought or a schematic on the internet, and that schematic did not come with a board view, you got ripped off. That's the first thing I'm going to say. Anybody who is, firstly, obviously, for very obvious reasons, you're not supposed to sell schematics. That's why I ignore every single one of your requests for schematics. I ignore them all because I am not getting myself in a deep shit by selling them or giving them away or distributing them in any way. But for the people who do sell them, who are engaging in that illicit activity, if they are giving you a schematic without a board view, you got played, you got ripped, you got owned. You need a board view. So let's say I want to see where R5281 is. I don't go and find it. No, the software, it tells me where it is. So now I know that it's over here. If I want to know where a certain voltage rail comes up on a machine, I do this, I hit N in this program, I type it in, and it shows me all the different points that it shows up. Again, I wasn't born knowing where everything is on this board. Nobody is. It's not magic. It's a program that tells me. And again, you really should understand why it is I can't answer anywhere where you get this stuff or how to get this stuff. You need to be somewhat self-reliant. You need to use your brain a little and use Google a little to find it. And I need you to understand why it is I'm not going to be the one distributing this or giving out knowledge on where to find this stuff. That is not something I intend to get involved in. But this is how you read schematics. You use all the knowledge that I've put in all these videos and you put it together and you combine that with usage of your brain. And when you combine usage of your brain with knowledge, with the ability to Google, you get the ability to read a schematic and to understand what's going on. And that's about it.